Good morning. Today is the, I think it's the fourth day of the week. Yeah, Thursday. I think it's Thursday. Thursday the 21st. And I'm doing this video because I am not going to have class today because I've got to take my mother to her general checkup. And I don't like for her to drive because people are mean and with road rage, and she's older. She's almost 80 and she's drives slow, and I don't want to have to kill somebody. So that's why I want to take her to the doctor. Anyway, I wanted to go over a few things, the rest of chapter 2, and these are on limits. I might have covered the first one. I can't remember. So I'm just going to start from the beginning of the algebraic limits, because I want to show you where we're going with this, because you should be able to work on chapter 2 material after I went over the graphing part of limits. Now I'm going over the algebraic part of limits, or the analytical part. And the first one we're going to talk about is limit as x approaches -4 of x squared minus x minus 20 over x plus 4. And as we talked about, and we did this problem the other day, as we talked about, there's several, well, I'll tell you what, let me go back. The limit, the actual limit problems, there's two types. There's your graphing limits, and that's where you have a function like this, and they say, what is the limit as x approaches -2? And -2 is right here, and that spot right there is +3. So your answer there would be 3. And we also went over the graphing sections where you have a dot up here and an open circle right here. And if they ask, and let's say that's 3, what is the limit as x approaches 3? And of course that would be, let's say that's 1. But what is f of 3? F of 3 is, that's 4, 5, let's say 5. Okay? Because that's inclusive. We talked about that. We talked about if the limit of one function is equal to, say, 4, and the limit to another function is equal to 8, then they're not equal, so the limit does not what? Does not exist. We also talked about if you have a vertical asymptote, and I'm just trying to draw all this on one graph. There's your volcano. Okay, what is the limit? What is the limit as x approaches 0? Does not exist, because it's a vertical asymptote. So you've got 4 or 5 different types of graph representations of limits, and that's the first part that we went over. The second part is algebraic. You're going to have simple plug and chug. I think we went over that the other day. Okay, where you have a limit as x approaches 4 of 2x plus 6. And that would be 2 times 4 plus 6, which is 10, plus 6, which is 16. All right, we went over a couple of those problems the other day. So I call those plug and chug. B, factor. Factor or manipulate by rationalizing. Okay, that's the ones that I'm going to go over today. And the third is division. Okay, so I'm going to go over these 3 today. I already went over a couple of these. So I'm going to try to hit these 2 today. So therefore, y'all can work through chapter 2 material, and I'm going to show you at the end of the class today, at the end of the video, where this is going. We've already talked about with the difference quotient and applying the limit theory to the difference quotient, applying the limit theory to the algebra, and then you got calculus, and then we go into chapter 3, which is all calculus. Well, calculus concepts based on 80 to 90% algebra. Okay, so that's chapter 2 in a nutshell. So we started with this one right here. Limit as x approaches -4. And the first thing you would think, being that the first thing we went over was plug and chug, is plug and chug. Well, we're not going to plug and chug, because plugging and chugging will give us a undefined function, which is too easy. Remember, I told you, if something is too easy in calculus, then chances are it's not real. In other words, I plug in -4, I get, oh, that's an undefined function, I'm done. No. That means if it's too easy, usually you're going to have to manipulate. You either manipulate by factoring, rationalizing, or whatever kind of manipulation you can manipulate. Multiply by -1 on top and -1 on bottom. You got to do something. So in this one, we're going to factor because you got a reverse FOIL up top. And we need a negative, so that means 5 is negative. We need a unlike, so that means positive, over x plus 4. And of course, the x plus 4 is canceled. So our final answer is limit as x approaches -4 of x minus 5. And that's going to equal -4 minus 9. Now, I will also tell you this. At x plus 4 on the graph, and you need to write this down in red. At x plus 4 equals 0, you're going to get -4. And at -4 on the graph, you will have an open circle. Remember that. Because on a test, if you're asked to graph it, or if you're given a graph and there's one that has an open circle on it and the other one just has a function with a line, you pick the open circle where at -4, because in the original, you have to compensate for that -4 giving you a blown up function. Okay? That's a test question, pretty simple. Now, I will put more of a complicated reverse FOIL. You may cancel a couple of things out. You never know. But that is a test question, and that's what I would put on a test. Okay? So that's one. Let's do a nerd like this one. Let's do limit as x approaches 9 of the square root of x minus 3 over x minus 9. Of course, you start with the first method, plug and chug, and plug and chug gives you an undefined function. An undefined function means we need to do something else. So, but the x minus 9, we'll put that in red. X minus 9 is equal to 0. Therefore, at 9, at x is equal to 9, we have an open circle on the graph. So whatever this graph looks like, you're going to have an open circle. On a calculator, it may be just a little blip. It won't be an open circle. It'll be like a little blip, and there will be nothing there on the function. Okay. So now we know that. So that's inevitable. So we'll just put that in a little circle here, and we'll say we know this. Okay, we know that. But what else do we need to do? Well, we're going to have to do something, and I would rationalize the numerator here. Okay, I would rationalize the numerator because rationalizing the denominator isn't going to help you very much. So I'm going to do the square root of x minus 3 over x minus 9, and I'm going to multiply through by the square root of x plus 9. And you could go through and rationalize the denominator. You're going to get x squared minus 81, and then you're going to be back to where you were, because then you're going to get the same thing in the bottom. Something's going to give you 0, and that's not going to help you. So if rationalizing the denominator does not help, and that's what we'll do out here, if rationalizing denominator does not help, then go with numerator. Okay? So we do that, and we're going to get, I'll just write this in another color. We're going to get a minus b times a plus b is equal to a squared minus b squared. Shortcut number 3. Some of y'all still choose not to learn. Over. And that's going to give you FOIL in the bottom, which I really don't care about. So I'm just going to leave this x minus 9 times the square root of x plus 9. Now, what am I going to do up top? Well, that's going to give me the x, the radical is going to cancel there. And that's going to leave us with x minus 9 times x plus 9. Hold on a second. Okay. I messed up. Well, I'm looking to see if we could continue on. That's going to give you x minus 9 on. Okay, we can still go. We can still go with it. I think. Yeah, we can still go with it. I'm sorry. This is just another way. I did it a different way. Yeah, that's going to give us x minus 9. I was a bit worried there. X minus 9 over x minus 9 times square root of x plus 9. Now, the reason I stopped there for a moment is because when I did this problem on another piece of paper, I rationalized the denominator. No, I did a trick with the denominator. I squared the square root of x, and it was a little bit more confusing. So I'd rather do it this way. All right. And what happens to the x minus 9s? The x minus 9s cancel, and you're left with 1 over the square root of x plus 9. So now we're going to do limit as x approaches 9 of 1 over the square root of 9 plus 9. And oh, 3. I'm sorry, that's supposed to be, I'm going all over the place here. Yeah, yeah. Okay, I'm sorry. And that's going to give you 1 over 9, which is 1 over 3 plus 9, which is 1 over 12. Okay? And the way I did it, well, I'd rather just keep it this way, because there's another way you can do it, but it's a little bit more confusing. I'm making sure that I did everything right. Make sure. Okay. Again, this one you manipulated, and you couldn't. And the reason I used rationalizing, another reason, is because if you look up here, and I'm going to use a marker, yellow marker, there's no, I can't even see that. Can y'all see that? No, I can't see that. I'll use, I was going to use something bright. I guess I'll use a peach. There's nothing to factor. If you see, there's nothing to factor. There's no squares. There's no cubes. So usually when you see a radical, that's a good indicator that you're going to rationalize something. So that's that type of problem. So now we move into looking at the degrees. If the degree of the denominator and the numerator are equal, okay, if you've got a limit and the degrees are equal, then most of the time you can go with the coefficients. These are a little bit more complex. So if I give you limit as x approaches positive or negative infinity, and we're also dealing with infinity now instead of numbers, and I give you 4x to the 10th, I can't write today, 4x to the 10th plus 1,000x to the 4th over 5x to the 10th plus 4. Well, the first thing I'm going to look at, there's two things that I want you to highlight here. We're going to highlight them in, see if I got a green, because you really need to make a note of it. One, we're talking about infinity, which means you're going to have to think outside of the box. Two, the degree of the numerator, the leading degree, the highest degree of the numerator and denominator are equal. So I'm basically just going to take my red marker and I'm going to mark all of this out. And your answer is 4/5. So you take the coefficient of the degree, the highest degree, and that is your limit. Okay? And again, these are problems that dealing with limit as x approaches infinity. Okay? And that's really the third part. What I showed you a while ago, right here, when you're dealing with division, that's usually the ones where you're going to be dealing with infinity. So this is the third part. What if the degree of the numerator is less than the degree of the denominator? What do you do? Well, this is where you kind of break it down to just the degree terms. Break it down to degree terms. You're not worried, kind of like we broke this down to just the coefficients. Well, if this happens, then we're just going to break it down to 4x to the 10th over 5x to the, let's see, the numerator is less, that'd be 5x to the 15th. You just break it down to that. Okay, break it down to the degree terms. So let's, as x approaches infinity, I want to make sure we're still dealing with infinity, of 3x to the 7th over 5x to the 8th plus 10x squared, 10x plus 2. And I'm going to take my green highlighter and I'm going to focus. There's your leading degree in the numerator. There's your leading degree in the denominator. So I'm going to, excuse me, I'm going to mark out. Now, if you had a +1 up here or a +2, or you had something like this up here, you would mark it out too. But you would just leave the terms where before we just did the coefficients. Now we're going to plug in infinity. Now this is where you have to think out of the box. Okay, this is what I do when I do it. Limit as x approaches infinity of 3x to the 7th over 5x to the 8th. And I put in my head, I do 1, 10, and 100. Now you're welcome to go way higher than that if you want to. All right. If I plug in 1, I'm going to get 3/5. So I'm going to do this in a kind of the yellow because I'm mentally thinking. So as x approaches 1, I get 3/5. This is mental. As x approaches 10, I get, well, 10 to the 7th is going to be some big number. And this is going to be an even bigger number. So I'm going to get a big number over an even bigger number. X is equal to 100. I'm going to have still a big number over what? Even bigger number. Anytime you have the bigger number on the bottom, you're going to 0. So we're going to write that down in pink. Right here where we did the mental math, bigger number on the bottom in the denominator. Your limit is going to 0. Think about it. 1/2, 1/4, 1/6, 1/8, 1/10, 1/15, 1/20. What is happening? Your step is getting smaller and smaller. So in this case, your answer is 0. So we've done degree is equal. Degree is less than the numerator. So that leaves degree is less than the denominator. And y'all all know what that means. Remember your vertical asymptotes. When your degree of the denominator is less than the degree of the numerator, that means we're going to have to do some kind of division. That basically is it. Okay. Now, I don't mean long division like you did with your vertical asymptotes. I'm sorry, your horizontal asymptotes. Yeah, long division. So I'm going to put long division right here, and I'm going to put an X there. What division am I talking about? Division by largest degree. Okay, so if I give you as x approaches infinity of x to the 4th over x to the 3rd plus 5. Okay, then I'm going to divide everything by x to the 3rd. So here, I'm going to divide everything by x to the third. So here we go. X to the fourth over x to the third. X to the third over x to the third. Plus 5 over x to the third. And now reduce it. So that x to the fourth over x to the third is going to be x. And that's going to be 1 plus 5 x to the third. And I'm going to put my limit down here as x approaches infinity. And I got to think out of the box, because now I'm going to plug in infinity and think what's going to happen here. So infinity over 1 plus 5 divided by infinity is equal to infinity divided by 1 plus 0, which is equal to infinity over 1, which is equal to infinity. Okay, so if you want to think of infinity, think of it as 1,000. Okay, then that's going to be 1,000 over 1 plus 5 divided by 1,000. So that's 1,000 over 1, which is 1,000. Now, I've just given you 3 questions that will be on the test. You already know that you're going to get a couple of graphs. Okay, and graphs are not going to be the biggest portion of the test. Basically, multiply this by 2 or 3. That's how many questions you're going to have on limits. You're going to have about 8 or 9 questions on algebraic limits and a couple of questions on graphs. So let's do nerding with infinity and beyond. Limit as x approaches infinity of 3x squared plus 5x plus 4 over x to the third plus 7x. Now, in this case, you do have the denominator being more. Okay. Now, you could apply the second theorem and mark out the rest. Okay. And I think you're going to get a bigger number. You're going to get 0. So you know you can take out. Let's see, the denominator is less than here. I mean, the numerator is less than. So that means I can take out this and take out this, and I get 3 times infinity squared over infinity even bigger. Infinity even bigger means 0. So by the second law, I know, and you can do it by the second law if you want to, 0. I know it's going to 0, but I'm not going to do it by the second law. I'm going to do it by the third law, which division works with all of them. So I'm going to divide by x to the third. So 3x squared over x to the third plus 5x over x to the third plus 4 over x to the third divided by x to the third over x to the third plus 7x over x to the third. It's kind of like you can use complete and square with any polynomial. You can't use factoring with every polynomial. I can use division by the leading or highest degree term. I can do that with any, and it will give me the answer. So division works pretty much with any type. Or like I said, you could use the second, and you can mark this out and mark this out, and you get 3 times infinity squared over infinity cubed. Well, let's plug in 2. 2 squared is 8. 8 times 3 is 24. No, 2 squared is 4. Yeah. Over 1,000. 1,000 squared. This is going to be bigger. It might not be with a small number, but it will be for a big number. This is going to be bigger than this. Let me just put it to you that way. Because x to the third is always going to be bigger than x squared. as you get with bigger numbers. And that's what we're talking about with bigger numbers. With a smaller number like 2, you would get 12 over 8. And that doesn't work with 12 over 8. That's not infinity. That's 12 over 8 is what? 4, 3 halves or 3/4, or I can't think of it right now. 4/3. Then that wouldn't work right. But don't worry about that, because most of these are going to be designed where you do it with infinity. All right, so this is going to be 3 over x. I've got it written down here. I'm going to go ahead and write everything down. Plus 5 over x squared plus 4 over x cubed over 1 plus 7 over x squared. Now, limit as x approaches infinity. As the numbers get bigger and bigger, what am I going to get? I'm going to get 3 over infinity. I'm sorry, 3 over infinity plus 5 over infinity squared plus 4 over infinity squared cubed. Now, we all know that that's going to 0. Okay? And we know that 1 plus 7 over infinity squared is going to 0. No, well, this is. And 1 plus 0 is 1, so you got 0 divided by 1, which is 0. All right, let's try another one. Limit and negative infinity really doesn't matter. I mean, you can plug it in, you're still going to get the same thing. X approaches negative infinity of x to the 4th plus x over 5x cubed plus 7. X to the 4th divided by x cubed plus x divided by x cubed over 5x cubed divided by x cubed plus 7 divided by x cubed. And you plug and chug there, or simplify, you're going to get, I'll just write it down here, limit as x approaches negative infinity. And I got x plus 1 over x squared over 5 plus 7 over x cubed, right? So that's going to give me, if I plug in infinity, that's going to give me negative infinity plus 1 over negative infinity over 5 plus 7 over negative infinity. And that's going to give me negative infinity plus 0 is negative infinity. And 5 plus 0, let me do this, because anytime you have a number over infinity, that's going to go to 0, and that's going to go to 0. So 5 plus infinity is 5, and negative infinity over 5 is negative infinity. Now, I can tell you right now, these are not that difficult. But I have run into students, and I was one myself, that I had a teacher that did not explain to me what limits were. And then they tried to tell me how to do this algebra with limits, and I had no clue what they were talking about. So that's usually what happens. You have a teacher that doesn't teach the limit theory, and the whole time you're doing this, you got to think half a step of the previous step, half the step of the previous step, half the step of the previous step. It's smaller and smaller and smaller. Limit as x approaches infinity of x plus 3 over the square root of x squared plus 4. Now, this is a more challenging problem And I'm just going to go over here and I'm just going to say, well, I know mentally, I know that the square root of x squared is equal to x. I know that. So if I was to square the square root of x squared, I would get x squared. So I'm just thinking along those lines. Okay? We know that x squared is the highest degree. Okay? So that means I need to divide or multiply. If I divide by x, dividing by x is the same thing as multiplying by 1 over x. That's the multiplication symbol. Let's use a star. Dividing by x is the same thing as multiplying by 1 over x. Make sure you understand that. So I need to multiply by something to divide by. I need to multiply by something, 1 over x, in this case 1 over x, to get something to cancel out. So I'm going to multiply by 1 over x on top here, mainly because the square root of x squared is x. That's where I get my 1 over x. I'm dividing by x. And then I've got 1 over x multiplied by x squared plus 4. Well, the only way we can multiply through a radical is with another radical. Let's go back to algebra 1. I can take the square root of 6 times the square root of 2, and that's equal to the square root of 12. So I can multiply a radical times another radical. But I've got to fix this right here to look like a radical. So I'm going to take the square root of 1 over x squared. I'm going to change this into the square root of 1 over x squared. Okay? So I'm going to rewrite this. 1 over x times x plus 3 over, and I'm going to leave this in pink, the square root of 1 over x squared times the square root of x squared plus 4. A lot of people say, well, can you do that? Well, you tell me, what's the square root of 1 over x squared? 1 over x. Well, that's what I'm doing. I'm multiplying by 1 over x on top and 1 over x on the bottom. This just looks different. What's 1/2 is the same thing as 50/100ths, but you don't see a 50/100 inch or a 50/100 cup of flour. Okay, so that's going to give me x over x plus 3 over x over, well, if I take the square root of this, that's going to give me the square root of 1 plus 4 over x squared. And now I can plug in the limit as x approaches infinity. And that's going to give me 1 plus 3 over infinity over the square root of 1 plus 4 over infinity. And of course, let's take our pink marker, and that 3 over infinity turns to 0, and that 4 over infinity turns to 0. And what is 1 over the square root of 1? 1. So in this case, the limit is equal to 1. I have one more that's a little bit challenging, and that's going to be the limit as x approaches negative infinity of x cubed over square root of x to the 6th plus 4. And I'm going to go over here mentally, say to myself, Well, the square root of x to the 6 is equal to x to the third. Okay, yeah. I did that just in my head, just like I did the last one. Okay. So I know I'm going to multiply by 1 over x cubed, because that way I can change it into the square root of 1 over x to the 6. Okay, now since this is negative, right here, I'm going to make sure that whatever I multiply on the bottom down here is going to be negative. Okay, and that'll make things a whole lot easier. Don't ask me why. I mean, I could show you the derivation, but it just makes things a whole lot easier. Just like, why do I on completing the square, why do I multiply the right side by the what I factored out with? Because it's just nice to do that. Okay. If you want to go through the derivation, you're welcome to look it up on Google and go through it. All right. So let's go with multiplying by 1 over x cubed. So I'm going to multiply the top. I'm just going to put that step right here. 1 over x cubed and 1 over x cubed. Now, of course, I can't multiply the bottom, so I'm going to change 1 over x cubed into the square root of 1 over x to the 6th. So I'm going to rewrite everything. The top, I'm going to just get a 1. And the bottom, I'm going to rewrite 1 over x. I'm going to rewrite this as the square root of 1 over x cubed, and that's a negative. I'm sorry, x to the 6th, times the square root of x to the 6th plus 4. And that's going to give me 1 over negative 1 in the radical. And that's going to give me a minus what? 4 over x to the 6th. Apply my limit. X approaches negative infinity. And that's going to give me 1 over the square root of negative 1 minus 4 over negative infinity squared, or 6, which we know that goes to 0. And that's going to give me 1 over negative, that negative is outside, I'm sorry. Well, we can look, yeah, it needs to be on the outside. That would be negative, sorry. That'd be a positive and positive. 1 plus 0 is 1. So it's going to be negative square root of 1. Excuse me. Sorry about that. Leave the negative out front, because you can't. There we go. All right. And that's going to give us negative 1. Now, those are several test questions. I can't remember how I think we did 3, 4, 5, 6, 7, 8. We did about 8 or 9. There's some good test questions there that I just went over. As you can see, I'm not going to try to trick you. I'm relying on your algebraic skills to manipulate these problems. Now, where is this heading? This is heading, now that you've gone through a chapter of limits, and you know what a limit is, and you know that limits are basically convergence. If I spell that right, I don't know if it's E or A. I can't get E and A and C. I can't get that right or not. I don't know if it's E or A. But basically, limits is convergence, meaning that you get within a hair distance. But you never, what? You never touch, which basically means exclusive. Because you never what? You never touch the number, so you never use that number in the formula. Okay? You always get close to it. And you're going to combine that with your algebra. And what in the algebra? Your difference quotient. And I believe this is where we see 3.1 and 3.2. I think that's why they put it in the Unit 1 test, but we're not going to do that probably. We're probably going to move 3.1 and 3.2 into the Unit 2 test. That way it's all together. But I'll check that and let y'all know what we're going to do there. What this is basically Chapter 2. Okay? This is your review and Chapter 1. Okay? Chapter 3 is when we actually get into calculus. Okay? So the difference quotient is f of x plus h minus f of x over h. And that's your algebra that you learned. And over here, limit as h goes to 0 of f of x plus h minus f of x over h. And what that's going to do, it's going to take out the h terms and leave you with what's called the derivative. And when you do these two together, that equals the derivative. And that is what we get into with Chapter 3. So that's where we're headed. Okay? So just for giggles, I'm going to do one just to remind you and apply the limit theory. So that way, those of you that want to go ahead and get started on 3.1 and 3.2, you can knock it out. So let's do limit h approaches 0 of, I'm just going to go with something simple. I'm going to go with a simple parabola. X squared plus 4x plus 4. And they will tell you in the directions, they will say use difference quotient to find the derivative or something like that. And that's in Chapter 3.1 and 3.2. It'll say something to that effect. So that means I'm going to plug in, I'm going to take my blue marker because I always use the blue brackets. Minus, what other color brackets I use? Maybe green, I don't know what I used. But I always use different color brackets when I do this. And f of x is x squared plus 4x plus 4. And f of x plus h, that means I got to use a big set of parentheses whenever there's a plus 4 times a big set of parentheses plus 4. And I'm going to plug in x plus h. And all that's going to be over h. And limit as h approaches 0. So the blue is going to go shortcut number 1 right here. So that's going to be x squared plus 2xh plus h squared plus 4x plus 4h plus 4 minus, remember that minus, it'll get you. Let's paint that minus red because it will get you. We're going to put a minus here and a minus here and a minus here. That's going to give you x minus x squared minus 4x minus 4 all over h. Limit as h approaches infinity. 0. Always put this because you got some teachers that'll mark it wrong if you don't put the limit in front of it. Okay, so let's see what cancels. I'm going to take my red marker, and that x squared cancels, and that 4x cancels, and that 4 cancels. That's going to leave you, most of the time, it's going to leave you with h term and numerical terms. So limit as h approaches 0 of 2xh plus h squared plus 4h over h. And I'm going to take out a h, and that's going to give me 2x plus h plus 4 over h. And what happens to the h terms? They cancel. And remember, you have the limit. So I'm going to go to the next page because we need to do this right. So I'm going to go to the next page. I'm going to fold this. Okay, so we've got the limit as h approaches 0 of 2xh plus 4. And here is where chapter 2 comes in. What do we do when we have a limit and we have h approaching a number? We plug and what? Plug and chug. So that leaves us with 2x plus 0 plus 4, which gives us our answer. Our derivative is 2x plus 4, and that is what we call the derivative. And that is chapter 3. Okay. So that's where we're heading. So now that we have completed chapter 2 material, we need to start sending questions. Y'all need to start sending me questions, because if I don't receive any questions in the next, or if I don't, let's see, today's the last day of class. So if I don't receive questions Monday, then that means y'all understand it and we're moving to take the test soon. And that means probably I'll go over the test Monday or Tuesday if I don't receive any questions. Okay? Now, that is today's class. I'm giving you all a day off today, so use it wisely. Work on chapter 1 homework, chapter 2 homework, and make sure you send me those questions. And please, go ahead and send me the ones that are stupid, the ones that don't have help me solve this, and I'll try to figure them out. But those are not going to be test questions. I can guarantee that. All right, I'm going to shut this off, and y'all have a good weekend.